Hey guys, we're going to continue Unit 6 with multiplying exponents and exponents that are to the power of a power. Yes, that's possible. So let's move on, get through this. So first off, for any algebraic expression, we always want to write it in simplest terms. So that means getting rid of those negatives that we talked about yesterday, the negative exponents. So also, again, here's just a little checklist. The same base does not appear more than once. No powers are raised to the power, so we're going to learn how to get rid of power to the power. And no products are raised to the power. And we'll look about how to get rid of that. Now, the last two I crossed out because we haven't talked about division yet, but we'll talk about that coming up pretty quick. So in a nutshell, for the first rule, when you're multiplying exponents, you're adding them. And you don't even have to memorize that rule. It's on your formula chart. It's pretty easy. It looks like this. Now, the important thing to remember is the base has to be the same. I can't do this if the bases are different. It's like combining like terms. I can't combine unlike terms. So let's see what that looks like. For the example A, it'd be like taking the 5 and the 6 and just adding them, which would make it 2 to the power of 11, which if I worked out would be 2048. I can do that because the bases are the same. But in the next example, we have 4s and we have 3s. So I'm going to combine the 4s and I get 4 to the power of 8. Now if I combine the 3s, I get 3 to the power of 5. So that would be 4 to the power of 8 times 3 to the power of 5. And if I put that in my calculator, it is this huge number, 15,925,248. Crazy. Whoops. There you go. All right, so here we have variables. So it's just a big matching game. So I have two A's, and if I combine those two, I have A to the power of 5. The B doesn't have a friend, and neither does the C, so we're going to leave them alone. All right, D messes people up a lot because the Y that's sitting by itself is actually Y to the power of 1. So this is going to be, let's see, 4 plus 1 plus a negative 9 is Y to the negative 4. You remember our rules from yesterday. We have to push it down. So it becomes Y over 4. And now I'm done. Let's look at the next one. We have numbers and we have variables this time. So I'm going to combine like terms. 2 times 6 is 12, and then it's x to the power of 13. Remember, they have to be like terms. The next one, if I look at all of the numbers, negative 3 times 4 times 3, I get negative 36. If I bring the z's together, I have z to the power of 5, and the w is just kind of by himself, and I'm done. Now, it is okay to have a negative in front of the number. It's the exponents that can't be negative, so keep that in mind. You don't have to get rid of that negative in front of the 36. Next one, if I combine the numbers, I get 36. D does not have a friend, and F does not have a friend. But I need to move that F down because it's negative. So I'm going to do 36d to the power of 3, and then the F to the power of 5 is below. There we go. Next one, I've got negative 4 times 5, which is negative 20. And then I've got a ton of S's. I've got times S. Oh, my 5s and my S's always look the same. Negative 3 minus 6 minus 4 ends up being negative 20S to the negative 13, which of course I've told you before I need to push it down. So now I have negative 20 on top s to the power of negative 13 below. So there's my final answer. Again, whoops. Let me take that negative off. Now that is a mistake that some students will make. They'll push it down and then they will leave the negative on there. So do not make that mistake. I almost made it. The negative is okay on the 20. You can leave the negative there. All right, now we're going to look at, if I say something is 3 times bigger, I multiply times 3 if I want to know what it is. Well, what if I'm going to multiply something by scientific notation? Scientific notation is a way to write really big numbers in a shorter way. That's what scientific notation is. So when I say really big, I should say a number that has lots of digits, because a number could be really, really a tiny number, but it just has lots of digits. So we write in scientific notation. But what if I wanted to multiply something by scientific notation? So we have Rhode Island. It's the smallest state, and it's 2.9 times 10 to the power of 10. That is the size in square feet of Rhode Island. But Alaska is 5.5. It's the largest state. And it's 5.5 times 10 to the power of 2 times bigger. So how big is it? So we're basically saying I'm going to multiply this times this. So first off, I'm going to pull those numbers out. 2.9 times 5.5. All right, got my numbers together, my like terms. And then if I bring my exponents together, it's 10. It's 10 times 10 to the power of 12. All right. Now, if I multiply those two numbers together, I get, what do I get? I get 15.95, 10 to the power of 12. But look, with scientific notation, when you write scientific notation, it has to be, that first number has to be between 1 and 10. So I'm going to move the decimal over because 15 is not in between 1 and 10. So I'm going to move this decimal over one place. But if I move that over one place, I have to add another power of 10, because that's what I just did, because I moved the decimal over once. It's like adding another power of 10. So my final answer ends up being 1.595 times 10 to the power of 13. Isn't that fun? Because this says to write your answer in scientific notation. So don't work it out. Don't try to get an answer to that. You could work it all the way out, but it wants it written in scientific notation. All right, power to the power. So I don't know if you've ever seen a number that's like 5 to the power of 4 to the power of 3. Did you know you could do that? Yes, you can. And so that's what we're looking at, power to the power. So power to the power, if you see it, it actually is, now I do multiply the exponents. So in this, here's an example you can kind of more wrap your brain around. 6 to the power of 3 to the power of 7 is the same as 6 to the power of 21. So this would be 7 to the power of 12. And I don't have my calculator. I wish I did. You should work it out. But we're just going to leave it as 7 to the power of 12. The next one is, it's a variable, so I won't be able to work it out. But it's the same as saying 3 times 5. So it's d to the power of 15. Next one is, let's see, we have exponents. So I'm going to do, these two are going to get multiplied together. So this is x to the power of negative 10 times x to the power of 3. Okay, now we're back to the other law we just learned a few minutes ago, where I'm multiplying them. So I'm just going to add them. So this becomes x to the power of negative 7, which brings us back to the rule before that we learned yesterday, where we're going to push this down, and it becomes 1 over x to the power of 7. Isn't this fun? Are you having fun? It actually isn't that bad once you get in the habit of it. And especially you can look at your formula chart anytime. All right, so now we have in parentheses to the power of 4. which means all of these are going to be to the power of 4. So negative 3 to the power of 4, and it's the whole negative 3. So that's the same as negative 3 times negative 3 times negative 3 times negative 3, which is a positive 81. And then x to the power of 4. Now watch this, because this is going to mess some of you guys up. The next one, the negative is on the outside. So this is different. This is like saying negative 1 times 3 to the power of 4 times x to the power of 4. So now it will be negative 81 x to the power of 4. So keep that in mind. It's different depending on if there's parentheses or not. Okay, let's look at this one. It's going to distributing that exponent all the way out. So this is x to the power of negative 6, y to the power of 6. So this one, I have to push that down, y to the power of 6, x to the power of 6. Okay, and this one, this is going to expand to these two, or distribute to those two, but not to the 3. So I have 3 g to the power of 8, h to the power of 12. Okay, the next one we're not going to do because it actually has division in it, and we haven't learned that yet, so it shouldn't be there. It's a mistake. Okay, the next one. Here's another one where we have something that is, I'm multiplying by an exponent. So I have 344 times this. I said exponent. I should have said in scientific notation. This much faster. It's talking about the speed of light, speed of sound. I love all this kind of stuff. It's so cool. The numbers are so cool. All right, so I'm going to go ahead and multiply this out. So the numbers I can pull apart, they can be separate. And then, again, I'm just dividing this up so you can see. I'm going to keep the exponent over here. It doesn't have anything to multiply with at this point anyway. So the number becomes pretty big. What's that too big of a number? 2,992.8. And that's times 10 to the power of 5. But there's a problem with this. It has to be written in scientific notation. So I need to move this decimal over 1, 2, 3, which means I need to add 3 over here. So now I have 2.9928 times 10 to the power of 8. And this is meters, can't spell, per second. All right. Good luck. Ask questions if you need anything. Bye-bye.